Day 70, Layers of Earth. Today's purpose, I will learn about the four main layers of Earth. The relevance to our lives. Motion of these layers cause earthquakes and volcanoes that we hear about in the news. And how will you know if you're a success or not? I will be able to construct a model of the Earth's interior. Our lesson plan for today. We're first going to read through some notes, layers of Earth, as we have on this page, and then we're going to cut out and arrange pieces on the next page to illustrate the layers of Earth, and then we're going to have 14 questions. Now, you do not have to listen through this YouTube video if you want. You can just go ahead and read the passage and then cut out the puzzle pieces and glue them on the appropriate page if you want, and then go on to answer the questions. You do not have to listen through this whole video. The notes. Layers of Earth. Although humans spend every day on the crust of the Earth, we tend to take for granted the incredible physical features that the Earth displays. For example, downhill skiing would be impossible without the hills and mountains. And how do these mountains form? It is easy to assume that they are not formed for the sole purpose of downhill skiing. The strength of the Earth's movement is amazing. Natural disasters, such as earthquakes and tsunamis, are caused by the heating and movement of material below the Earth's surface. To understand the formation of physical features of the Earth and the natural disasters, we must probe beyond the surface of Earth. The inner layers of Earth do have an effect on our daily lives, and it is important to know what is beneath the surface that we live on and how it works. Layers of the Earth according to density. When seismic waves, that is, waves given off by earthquakes, when they are studied, seismologists notice a change in the wave's speed as it travels through the geosphere. Waves speed up or slow down when they enter material that is a different density. From these studies, geologists have identified four layers of the Earth: the inner core, the outer core, the mantle, and the crust. The inner core. The inner core is the densest of the four layers. It is the deepest layer of the Earth's geosphere. It is a 1,500 kilometer thick layer of solid iron. Now, nobody's been down there. We've never taken samples of it, but that is our best guess as to what's going on with the evidence that we have. The outer core. The outer core is the next densest of the four layers. It is a 2,000 kilometer, 1,243 miles, thick layer of liquid iron and nickel. It is the only liquid layer of the Earth's geosphere. The mantle. The mantle is the second densest of the four layers. It is about 3,000 kilometers, or 1,864 miles, thick, and it makes up 80% of the Earth. Since the mantle is so thick, the amount of heat and pressure significantly changes within the layer. Near the outer core, the mantle is mostly solid rock with a small amount of molten rock. The middle part of the mantle is semi-melted rock. This layer has solid rock, but it is more flexible. It is more like flexible Play-Doh than brittle rock that we see on the surface. Because of this flexibility, it can flow in convection currents up and down. Hot rock rises and cold rock sinks. Near the crust, the mantle is solid. The main elements in the mantle are silicon, magnesium, iron, and oxygen. Here is a picture of the convection currents, and we have the hot rock flowing upwards and the cold rock flowing downwards. And it just apparently keeps on going around and around like this in what we call convection currents. The crust. The outermost layer of the Earth is the crust. Geologists identify two types of crust: continental crust and oceanic crust. Continental crust makes up the continents and is from 20 to 100 kilometers thick. It is mainly made of the metamorphic rock granite. Oceanic crust is found under the Earth's oceans. It is 5 to 10 kilometers thick. It is mainly made out of extrusive igneous rock called basalt. Areas of the Earth according to physical properties. In addition to the 4 layers of Earth, geologists divide the geosphere into areas based on the state of the rock, whether it's solid or liquid. There's never gaseous rock. There are 2 areas that are vital to understanding the theory of plate tectonics. One area is the asthenosphere. It is a semi-melted area near the middle of the mantle. The other area is the lithosphere. It consists of the solid crust and the solid upper part of the mantle. During the remainder of the unit, we'll be studying the interactions of these 2 areas as the lithosphere, which is broken into plates, moves around on the convection currents in the asthenosphere. Now then, we are going to be looking at the puzzle pieces. You should have a page that has all these different pieces that you're going to be cutting out and putting together. Let me raise this up. So you're going to cut out these pieces, and they should only fit together in one way. And when you put them together, they should look like this. We have the thin layer of crust on the outside, and then we have the mantle, and then the outer core, and the inner core. Notice we have descriptions of each one of these sections. The outer crust is described as being either oceanic crust or continental crust. The mantle here, we have 1,800 miles. It is flexible solid rock. Parts might be melted. And that in this mantle, we have convection currents going around and around, where you have hot rock rising and cold rock sinking. Then we have the outer core. It's liquid iron and nickel, and it's about 12,000 miles thick. And then we have the inner core. The inner core, we think, is solid iron. Please glue that on the appropriate sheet and show it to your teacher.